Imagine you're in a dark room. You're told a bright light will switch on in 3, 2, 1. But something strange happens in that final second, even before the first photons hit your retina. Your pupils, the black apertures at the center of your eyes, have already begun to shrink. This isn't a reaction to light because there isn't any yet. It's an anticipation, a physical, measurable change in your body based on a prediction of a future event. How can your eyes react to something that hasn't happened? The common explanation is that pupil constriction is a simple reflex managed by the autonomic nervous system to protect the retina from being overwhelmed. And it is, but that's not the whole story. The anticipatory response reveals that this system isn't just reactive, it's proactive. It's taking cues, a verbal warning, a clicking sound that precedes the flash, and executing a command to prepare the visual system. This is your body's unconscious intelligence, a low-level prediction service that optimizes your sensory input before you're even aware of the need. This proactive behavior is a form of classical conditioning, but for your nervous system. In a 2012 study by Karen Hapuch-Edan and her colleagues, they paired a specific sound with a flash of bright light. Initially, the pupil only constricted after the flash. But after repeated pairings, the pupil began to constrict in response to the sound alone before the light ever appeared. The brain had learned the association and rewired a fundamental reflex. It had built a simple model of reality. This sound means bright light is imminent. It's not magic, it's your brain creating a causal link and acting on it. This phenomenon is a perfect window into a powerful theory of the brain called predictive coding. The idea is that your brain doesn't passively wait for sensory information to build a picture of the world. Instead, it actively, constantly generates its own model of the world, a cascade of predictions about what it expects to see, hear, and feel next. Sensory input, like light hitting the retina, is primarily used to check and correct these predictions. The pupil constricting early is the brain saying, "My model predicts a high light environment soon, so I will adjust the camera settings now." This isn't just a high-level cognitive process. The hardware is deeply embedded. A key structure involved is the superior colliculus, an ancient part of the midbrain. It's a crucial hub for orienting attention and controlling eye movements, but it also sends signals to the pupillary control centers. When you anticipate an event at a certain location, your superior colliculus is already active, directing your internal spotlight. This attentional signal, in and of itself, can influence your pupil size, preparing the eye for the information it expects to receive at that specific spot. And this predictive adjustment goes far beyond light. Your pupils dilate when you are doing complex mental math, not because you need more light, but because your brain is allocating more cognitive resources. They widen in response to emotionally charged sounds or images, preparing you for a potential fight-or-flight situation. They even change based on uncertainty in decision-making. Your pupil size is a direct, honest signal of your brain's cognitive and emotional state, a real-time readout of its predictive engine at work. Every subtle change is an adjustment based on a forecast of what's coming next, whether it's a photon or a thought. Why go to all this trouble? It's about efficiency and survival. Pre-constricting the pupil before a bright light hits prevents the retina's photoreceptors from being momentarily bleached or saturated. This reduces the recovery time and ensures you can extract meaningful information from the scene as quickly as possible. Imagine an ancestor hiding in a dark cave when lightning flashes outside. Being able to see the predator revealed by the flash without being blinded for a critical second could be the difference between life and death. It is microscopic, preventative maintenance for your most critical sensor. So the next time you notice a light about to turn on, remember what's happening. Your body isn't just a passive vessel waiting for the world to happen to it. It is an active, simulating, future-predicting machine. It builds models, tests hypotheses, and physically prepares itself for what it believes is coming next. And one of the most elegant, visible proofs of this profound reality is happening constantly in the silent, subtle, and predictive dance of your pupils. Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.